Hello everyone. This video is going to talk about the concept of correlation and causation as it relates to argumentation. Keep in mind that correlation and causation is often associated with statistical analysis and data analysis, but for the sake of argumentation, authors who pose arguments often rely on the notion of correlation and causation in order to support their argument and claims, especially when the argument and claims expose notions of cause and effect, or as we call it, causality. When it comes to cause and effect situations in everyday life, it is only natural for us to want to determine what causes something or identify the cause of an effect, situation, event, scenario, whatever the case might be. Through this process, we often rely on what's called inductive reasoning. And inductive reasoning can be formed through our experiences, our observations, things we know to be true, observations of others, or our own biases. And what often results is us drawing conclusions about what appears to be the cause of something. Now, we can approach this in a way that allows us to draw temporary conclusions, but as far as drawing absolute conclusions about the cause of something, this can be a dangerous approach, especially as it relates to understanding information or drawing conclusions about something, or more specifically, when we want to make decisions or make choices about whether or not to do something. If we look around enough, we will see correlations are everywhere, but we want to ensure that when it comes to argumentation, that an author is not necessarily trying to pass off correlation for causation. As a real-world example, on the left-hand side, we can see, especially as it relates to our health, that there are instances where we often will experience certain symptoms, for example. We can say that we have a headache, we can say that we have nausea, abdominal pain, loss of appetite, or body ache. Now, these are all symptoms of something, and we want to know what causes these things to occur. Now, it's only natural for us to say something like it's the flu, right? Because we know that it is true that the flu can absolutely cause these things. But if we are just simply saying, I have these and therefore it's the flu, absolutely, well, that might not necessarily work. We need things that should be able to prove that the flu is the thing that's causing this. But when we look closely, we can say that this is caused by IBS or menstruation, the flu, COVID-19 now, or potentially depression, okay? Now, how do we prove which one is the actual thing that's causing this? Well, we might run a series of tests, for example. We might run a series of blood work that will be able to identify that. This will absolutely prove causation of which one of these is actually causing this. But without this here, we are only making correlation cases. Now, it's not necessarily a bad thing, like I said, but it could be a starting point to want to get to determine what's actually the cause of it, because if misdiagnosed, obviously, it could present a problem. As I said before, correlations are in fact everywhere, right? We examine data or information long enough, we might also want to say that, well, I can determine what the cause is of something if I just look hard enough. But in argumentation, authors attempt to take advantage of the way readers approach information. So often we might find ourselves taking a very passive approach. Like I said, in the example before, if I say I have a headache or abdominal pain, I might be passive about it and just associate it with a particular cause instead of, number one, going to the doctor, or number two, making sure to get blood work or whatever the case might be in order to address the actual cause of it rather than just addressing the symptoms of it or alleviating the symptoms for that matter temporarily, like with ibuprofen or other pharmaceutical drugs. Now, in this case, it's the reader's job to evaluate arguments, right? Especially for causal claims, because we want to know if the author is solely relying on correlation to prove causation. And if that's the case, it weakens the argument substantially, especially if the whole argument is filled with them. So what is correlation? Well, correlation, obviously, as I said, is a term in statistics, and it refers to the degree of association between two random variables, okay? Now, the emphasis, of course, is on the word random because it can be random. They don't always have to be, but oftentimes there are two random situations that we want to find the association between the two, or at least the degree of association. So with that being said, then we look at data sets. It could be two data sets or more, obviously. And in many cases, they can resemble one another. So if we look at it in these terms, if A and B tend to be observed at the same time, right, then we are pointing out that there is a correlation between A and B. Now, we're not necessarily saying that A is the thing that caused B to occur. We're just saying that these two things occurred at the same time. They don't necessarily prove that A is the thing that caused B. Now, in a lot of ways, when we think that these things that move together or show up at the same time, that sometimes causes us to think that this is the cause of something. So, for example, A can equal, let's say, the rain, okay? And then B can also equal increase in traffic, okay? So on its own, these two things are two separate random variables, right? We have rain and we have increase of traffic. Now, that doesn't mean that rain causes the increase in traffic, right? It just means that if, let's say, I observed, or at least someone claimed, that every time rain occurred, I noticed an increase in traffic, well, again, it doesn't show that rain causes the increase of traffic. It could very well just mean that every time it rains, I happen to be outside and observe that at that particular time when it's raining, I notice an increase in traffic. But that doesn't necessarily mean, again, that A is the thing that causes B. When we look at causation, on the other hand, what it is applying is that A, in fact, equals B, or that cause and effect, A causes B to occur. This is known as causation, or that it shows or proves causality. So number one, that the causation means that these two events appear at the same time, or one right after another. And it also means that these two variables not only appear together, but that they show the existence that one causes the other. So these two things need to happen at the same time in order for something to be considered as causation. So for example, let's say that A equals working out or exercise, right? Okay. And then here we have B equals muscle growth, okay? So we can absolutely say that by working out, muscle growth occurs because we have scientific proof that this is what happens, absolutely happens. Now, we're not necessarily saying how much of it, because that doesn't necessarily equate to the workout. We can't just say I work out, this is why what caused a significant increase in muscle growth. But what we can say is that working out causes muscle growth to occur. Okay, we know that working out is not going to cause, muscles to wane or anything like that. Now, it may happen, but that could be another variable that's causing that. Again, we have to treat these as, if we're making the claim working out equals or causes muscle growth. Okay, so this would be causation. We also know, if we were going to talk about the rain example, rain, okay, we know that rain can also, or is necessary, I guess, for, plants to grow. We can say because it rained, plants grow. We can also say that watering, but rain is a form of water, so we can say that this causes this. Now, again, we have to be careful how this information is presented in the context of an argument, so we have to evaluate those things carefully. So why does this all matter? Well, knowing the difference between correlation and causation makes a huge difference, obviously, because again, we're basing a decision off something. And if the decision is erroneous or is false, We could say this is a logical fallacy naturally, because that is considered one logical fallacy, and one of those popular post hoc ergo propter hoc. Please review the fallacy video to understand that concept. But again, in argumentation, readers, you have to choose to accept a conclusion or to reject it based on information and data. And if a majority of the arguments or claims that are being made rely on this kind of data or information or cause and effect situation, and they're relying solely on correlation in order to make those claims, they can be tricky sometimes, right? And this weakens the argument, but we have to be careful in analyzing how they, or the author in this instance, is attempting to present the information. So it can be tricky, as I said, because information can be true, right? That something occurred and then something occurred at the same time. So for example, in politics, they might say, if a president takes office, for example, and we see this all the time. Okay, and then we could say the gas prices have gone up since that. But taking office as a president itself doesn't cause gas prices to go up, meaning a president occupying the space doesn't do that. But if we're talking about certain policies, for instance, or aspects that prove to show that this occurs, well, that's a different kind of conversation, right? But most people who are arguing this sort of claim will just say so-and-so is in office, therefore gas prices went up. And without going into depth or attempting to prove or show how that works, then we have a weak argument in that case. So how do we determine whether or not something is causation? Well, that happens through research studies. That happens through multiple experiences of personal experiences, for example, large data sets that prove that or show that. So different kinds of experiments that take place. And of course, replicating studies that'll allow us to corroborate information that might prove, causation versus correlation. So as an example from the article, Has Feminism Killed Art at Home Cooking? One of our claims is feminism is who we have to blame, or to thank in this case, for the spread of fast food chains. So that's claim number 1. And then in the other claim, we can say that, or she's making the claim that feminism is the thing that caused the increase in the actual epidemic of childhood obesity. Now, because it is phrased this way, this is the way that we absolutely have to take it. We can't make assumptions or assume what she meant. We have to evaluate the way that it is here. And so her attempt to show this is through one data. Recent NHS survey reported that nearly 1 in 3 11-year-olds in England is either overweight or obese. So this fact, of course, is that at this time that she's making this claim, so if we do A here, okay, feminism, and then B, simultaneously through the feminism occurring, which of course is ongoing, that 1 in 3 11-year-olds is overweight or obese. And because these two are happening simultaneously doesn't necessarily show that feminism is the cause of this fact to occur, or at least the way that it's presented here. Now, if there's information in this NHS survey that kind of talk about it, which I seriously doubt, then she's relying on correlation. Same thing for this other one here. She says, yet though many say they aspire to cook, the consumption of convenience food continues to rise. There was a 300% increase between 1997 and 2008. So this is attempting to show that the spread of fast food chains, of course, caused from feminism. And same thing again, we have A equals feminism. So we do fem. And then B is that there was a 300% increase. Just because those things occurred simultaneously doesn't necessarily one cause the other. And again, we don't have any mention of feminism or how feminism is involved in that way. So in this case, this would be a weak representation of relying on correlation, or excuse me, a strong representation of relying on correlation versus causation. And then finally, some last tips. Correlation is very important, obviously, because we're really wanting to establish or understand the relationships between these two variables. It could indicate a cause and effect relationship, but on their own, they can be misleading or uninformative. again, providing misinformation. And so unless we've really assessed the relationship of it or really actually found the meaning that connects these two variables, again, cause and effect, then we can't really make decisions based off those elements. And so one thing that you want to think about just in general everyday argumentation is to look around and observe the places in which people are making decisions or drawing conclusions about things, especially in causal relationships, and to determine whether or not they're relying on correlation to make those conclusions. Now, keep in mind, we don't always have as strong evidence or, data or information. So we have to rely on close analogies sometimes, but even then we want to evaluate those closely. So for your text and article that you are analyzing, there could be the potential that the author will present a causal relationship, and you'll have to ask whether or not that they rely on correlation or are able to prove causation.